Alright, so in this video what we're going to be looking at is solving log equations. And we're going to do these without the use of a calculator because it's just, they're not going to be extremely complicated ones. So here's the process we're going to follow. First we're going to condense our logarithms. We're going to use our properties that we've been using to expand and contract our logs. We're going to condense them down to smaller pieces. We're then going to convert the equation to an exponential form like we did a couple videos ago. We're going to solve for x, and here's a new piece that we're going to do today. We're going to check for what's called an extraneous solutions. And here's an idea I want you guys to make sure that you understand. Logarithms cannot act on negative numbers. So the idea here is that if I had something like log of -4, that's going to be a concern because I've got that negative number here. So it's going to have to be something greater than 0. So we're going to start off with an example. Log of x plus log of 5 equals 1. So my first step is going to be to take these log expressions on the left side and put them together using my properties. I see that I'm adding them. They do have the same base, which is good news, and I am adding them. So the way I can put these together is to take that x and that 5 and multiply them together. And it seems like we might be stuck here at some point, but if we remember that if a log doesn't have a number written that it's actually a base 10, then that makes things a little bit easier for us to continue. We're going to take our little loop trick with our exponents and make an equation. 10 to the first equals 5x. And I'm going to find out what x is. X is going to equal 2. And I'm going to double check. So when I take that 2 and plug it in, I'm going to get an expression, or an equation I should say, that's going to look like this: log of 2, which I'm okay with that, plus log of 5, I'm okay with that, equals 1. Everything checks out. I think we're good to go because I don't have anything that's an extraneous solution. Something that appears to work that doesn't. What about a question like number 2, where we've got log base 3 of x minus log base 3 of 4 equals 2. So here our property is going to be the division property. So I see we've got subtraction over here on the left side. I'm going to make that log base 3 of x divided by 4 equals 2. And go ahead and loop it around. X over 4 equals 3 to the second power. So that's going to give me an equation where I've got x over 4 equals 9. And so x would equal 36. So again, I've got my possible answer. I'm going to double check it. Log base 3 of 36. I don't see an issue there. Minus log base 3 of 4. Looks good. Equals 2. I'm not seeing any concerns. So x equals 36 will be our answer. Okay, what about this one? Let's set one up like this. Log of x plus 1 minus log of x equals 2. So again, I'm still going to follow that same idea. I want to condense the logs down first, making it log of x plus 1 over x equals 2. I'm still going to turn that into an exponential equation. So again, that's base 10. So I'm going to have x plus 1 over x equals 10 to the second. I'm just going to call that 100. So this is where these get a little bit tricky, is that we got to remember that this is actually really a fraction. 100 is 100 over 1. So then I can just cross multiply and solve. So I'm going to have 100x equals x plus 1. Take away x from both sides, I get 99x equals 1. X equals 1 over 99. And when I plug that back in, I'll have 1 plus 1 over 99. I'm cool with that. I'm going to have log of 1 over 99. I'm cool with that. And so I don't have an extraneous solution. So it seems like so far, like every single problem we're doing, we're never going to get an extraneous solution. But I'm going to tell you right now that that's not always the case. So what if we had one like this? Log of x plus log of x plus 21 equals log base 5 of 25. And I like this one for a couple reasons. One, we're going to get a quadratic on the left side. Good news. The other thing I like about it is that there's actually log expressions on both sides. And so I'm going to have to do something with that log base 5 of 25. So I'm going to start off by combining my left side, condensing it down to x times x plus 1. Oh, sorry, not 1, but 21. And on the right side, I'm going to rewrite this as log base 5 of 5 to the second. Now, if I think about that, if I were to loop this sucker around, I'm going to do this on the side, log base 5 of 5 squared equals x. If I want to know what that actually equals and I loop it around, I'll have 5 to the second equals 5 to the x. And so that side over here is going to turn into just 2. So what I'm going to have now is log of x squared plus 21x, I'm just multiplying those out, equals 2, which gives me, again, base 10, x squared plus 21x equals 10 to the second, which is 100. So I can bring that 100 over, set it equal to 0, factor. That's why I like quadratics, because you can usually factor them. I'm going to find out that x could equal negative 25 and x could equal 4. Now this is where we have to go back and again double check and make sure things work. If I take that negative 25 and I plug it in, I'm going to immediately have a problem. I can't take the log of a negative number. So this answer right here is an extraneous solution that doesn't work. But I'm going to check the other one just to be safe. Log of 4, I'm okay with that. Plug 4 in here, I'll get log of 25. I'm okay with that as well. On the right side, I know is going to be okay. So 4 would be my solution for that. Now what happens when we can't do that? When we can't take those things on the right side and simplify them a little bit. So if I give a problem like this, where I've got the log base 5 of 2x plus 3 equals the log base 5 of 3. Now, if we try to take that log base 5 of 3 and do something with this, I would write this over here on the side. Log base 5 of 3, you call it x. 5 to the x equals 3. I have no clue what power of x would make that work. So I don't see that working out too well for us. But I did notice that on the left side and on the right side, we had a log of 5. They are the exact same logs. So what I can actually do is take that log argument. Sorry if you're hearing my dog barking. How dare my neighbor grill on a nice day, you know, the audacity. I take 2x plus 3 and I set it equal to 3 and solve. Take 3 away gives me 2x equals 0 and x equals 0. So take that value, plug it in. I didn't have to convert to a log equation here. Take 0, plug it in. I'm going to get log base 5 of 3, which is exactly what I have over here. So I know that that is going to be a valid answer. All right, one more. Negative 2 log base 4 of x equals log base 4 of 9. I'm just laughing at my dog because he's going nuts out there. All right, so first things first, I do notice that I've got log base 4 on both sides. That's good news. So I could take my arguments and set them equal, but the problem that I have is I've got this negative out in front. So what I'm going to do is bring that in first and condense it that way. I'll have log base 4 of x to the negative 2 power equals log base 4 of 9. Once again, my logs are the same, so I don't worry about those. They effectively go away, and I'm going to have x to the negative 2 power equals 9. So what do we do with that? Well, if I have x to the negative 2 power, that's really the same thing as 1 over x squared. I can then set this over 1 and cross multiply, giving me 9x squared equals 1. So x squared would equal 1/9. This is taking a while to do this problem. And taking this plus or minus square root of both sides, I'd get plus 1/3 and minus 1/3 for my values of x. Again, take the numbers and plug them in. Plug a 1/3 in here, we're good. No problems. Plug a negative 1/3 in here, we have a problem because we've got a negative value for that log argument. So what I'm actually going to get then is just 1/3 as my possible answer, because the other one is an extraneous solution. Can't work.